Very much, Katie. At the last moment, my headphones decided to give out, so I will be speaking through the Mac speakers, so I apologize for that. But let me share my screen really quickly, and then we can get started. And what you also notice is in the Zoom presenter pane, there's two Alan Chens. So a colleague of mine, Lawrence, he's logged in to help answer questions during the session. So if you have any questions, please go ahead and ask it through the Q&A, and Lawrence can try to address it. If not, we can visit it at the end of the presentation. So thank you everyone for joining the session today. I'd like to give you a high-level overview of Aviatrix and exactly what Aviatrix helps solve for in public cloud networking. Just a little bit about myself. I've been at Aviatrix for just a little bit over a year. Prior to coming over to Aviatrix, I was actually an SE at Palo Alto Networks. I was one of the SEs in California, Southern California, supporting Orange County and San Diego. And I see some familiar names in the attendees list. So hi, folks. Good to get synced up with you again. And if you have any questions about Aviatrix, feel free to reach out to me. My LinkedIn information is here, as well as my email address, and all of that should be available with the Fuel presentation. So with regards to Aviatrix, what exactly is Aviatrix? So the term Aviatrix, the actual term it means a female aviator. Right? And the reason we're called Aviatrix is because the company was founded by a former Cisco engineer who happens to be female, and she recognized the lack of enterprise networking and troubleshooting capabilities in public cloud. Right? And this is how Aviatrix came to be. So if we think about the data center evolution, right? When folks started out with on-premise data centers, right? They had full control of their routers and switches, able to manipulate routing and packets as needed, and everything, ingressing and egressing from that data center would typically go through, one choke point, or the firewall or the edge gateway, right? In public cloud is very, very different, because essentially every VPC, every VNet that gets spun up is one hop away from the internet. And what a lot of enterprise customers have realized is, for a lot of the cloud service providers, their focus is on the compute and the storage and advanced services like AI, ML, things like that. The networking component is really not as strong as customers are used to, having on-prem, right? If when in your physical data center, if you have any type of troubleshooting that needs to be done, you can have direct access to the CLI of that router or switch and be able to run your pings and trace routes and packet captures, et cetera. Right? All of that is missing with regards to working with networking in public cloud. Because again, if you think about it, AWS has Transit Gateway. Well, this Transit Gateway, it's a shared construct between a number of AWS customers. And so it's very difficult for AWS to provide that debug level access into that Transit Gateway, because if you're doing advanced troubleshooting or very high detailed debugs, it may affect other customers using that same shared service. Right? And so this is really the challenge that Aviatrix is looking to solve, is to bring enterprise-grade networking, visibility, and troubleshooting to a public cloud environment. And this is why around 600 customers have turned to Aviatrix to address their multi-region in a single cloud, or even multi-region across multiple cloud type of environments. We have customers in all different verticals. You can see Nike is a customer of ours, NASA, Audi. So really customers of all verticals and in sizes. They've turned to Aviatrix to solve a lot of their public cloud networking challenges. So how do you get started with Aviatrix? The Aviatrix starts with a controller, right? The controller, it can be instantiated in any cloud service provider of your choice. We have some customers that are leveraging Aviatrix if they may only be in AWS. We also have customers that have cloud presence in all 5 of the major clouds. The controller can be stood up in any cloud service provider. The features and functionalities are exactly the same. And what you'll notice is that with Aviatrix, it's not a SaaS or a managed service. The controller, as well as the Aviatrix gateways, they're spun up as compute instances within your cloud environment. So you own the data plane. Any packets within your cloud environment that's running over the Aviatrix fabric, they don't leave your organization's control, right? There's not like a backbone or anything that they travel to. You own the compute. The data plane is yours, and it's managed by you, right? What happens is when the controller has been instantiated, then you would onboard your various cloud accounts. We support all the 5 major ones here, as well as the China versions like AWS China, Azure China, as well as the GovCloud versions of AWS and Azure. And once your cloud service provider accounts have been onboarded to the Aviatrix controller, this then provides programmatic access from the controller into your cloud environment. So the controller, because it sits out of band, it's in its own management plane / control plane, and it sits out of band. So it has awareness of what's going on with your cloud environment. If there's availability zone issues, the controller becomes aware and can change routes as needed. And the controller will also program the routes, your AWS VPC route table, your Azure VNet user-defined routes to steer traffic towards our Aviatrix gateways. The controllers would deploy the Aviatrix gateway in each region in a spoken transit type of architecture, right? So it's a very repeatable, consistent architecture, between regions, between clouds. As many of you know, if you're working with AWS and you're working with Azure and GCP, the native constructs are so different between each of the cloud providers. So the knowledge and experience that you have with one cloud, it doesn't translate immediately to another cloud, right? And so this is really where Aviatrix comes in, is we can provide that same repeatable, consistent architecture between regions and between clouds. Once our gateways have been spun up, and the data is running over our gateways are extremely intelligent. They generate very rich logging information, very rich NetFlow v9 information, and we send that over to the Aviatrix Copilot. So Copilot, it's a part of the Aviatrix platform in that it is used for the day 2 visibility, troubleshooting, and analytic tool that is part of the Aviatrix platform. Right? We leverage the controller to build our cloud infrastructure, and then we leverage Copilot to do in-depth troubleshooting, to have visibility into our flows, et cetera. And after the presentation, we'll hop over into the controller and Copilot for a very brief demo. Another thing that we can do is from the Aviatrix controller itself, we can actually orchestrate and instantiate the insertion of next generation firewalls, very like the Palo Alto VM series. Since this session is a firewall focused session, we wanted to highlight the ease of inserting the VM series into your public cloud environment with Aviatrix. When I was at Palo Alto, I spent a lot of time helping customers insert VM series into AWS, into GCP, into Azure. And again, because the native constructs are so different, the experience that you have is, for one cloud, it doesn't translate to another cloud. And another thing to note is that the cloud service providers, they're constantly changing as well. When I first joined Palo Alto Network, the recommended design was all about the transit VPC. Right? Then about a year later, AWS introduced the transit gateway. So now the architecture shifted to now of a transit gateway type of design. And then AWS came out with gateway load balancer, right, for security insertion. And so again, the design has to change, right? And so with Aviatrix, what a lot of customers have benefited is, let Aviatrix adjust with the changing features and capabilities of the cloud provider. And for the Aviatrix customers, their design doesn't change, right? It's still a very repeatable, consistent spoke and transit architecture in each region. Right? And so that's another major benefit of Aviatrix is there's not a need to change your design anytime the cloud service provider introduces a new feature or capability. Another major benefit is Aviatrix, we are an official Terraform partner and provider as well, right? If your organization is on the path of leveraging infrastructure as code, what you'll find is whether you're using CloudFormation template or Terraform AWS, those same scripts cannot be used for Azure or GCP. Because Aviatrix, because we're an official Terraform provider, we have what's called multi-cloud transit modules and multi-cloud spoke modules, where the same Terraform configuration can be used to deploy our gateways, whether you're on AWS, Azure, GCP, OCI, or Alibaba. So, all right. Let's talk a little bit about the firewall insertion with Aviatrix. So with the Aviatrix controller, what we'll do is we'll insert the VM series at the transit layer. And you also have the full capability to determine what traffic you want to send to the firewall for inspection, right? For example, you may have prod or dev VPCs and VNets where those need to go to the firewall for inspection, and that could be easily orchestrated through the controller, right? You may have some VPCs maybe for backup traffic where they're long-lived flows and more trusted flows, and we don't want the VM series to have to leverage the CPU and memory to inspect those long-lived trusted flows. So you have full control over which VPCs and VNets you want to send to that firewall for inspection. The Aviatrix controller can also orchestrate the routing for the VM series, whether it's the VM series by itself, or if you're using Panorama, we can orchestrate the template and template stack within Panorama so that the appropriate routes are then pushed down to the managed firewalls. So if you think about it now, from a routing perspective, right, your cloud infrastructure team through Aviatrix has full control of the routing within their cloud environment and has full control of the routing on the VM series. And now we can lead the security team to manage the security policies on those VM series itself. Right? So if your organization has that separation of duties between the cloud infrastructure team and the security team, we can very well participate in that type of organizational structure. Right? All right. So let's kind of talk about what type of things the Aviatrix solve for. As we already mentioned, each cloud service provider, the networking is done very, very differently, right? For AWS, their logical construct is called a VPC, and their transit solution is a transit gateway. In Azure, it's VNets and vWAN, or they have a route server that just came out. GCP uses the same acronym as AWS VPC, but their VPC is much different in that it's a global construct, whereas AWS is a regional construct. And so unless you're involved in playing around and configuring, in these cloud service providers on a daily basis, you may not understand the capabilities or the limitations of each of these constructs within each of these CSPs. And this is really what Aviatrix is helping to solve for, right? So once the controller has been instantiated, right, and we onboard your account, then the controller can perform various functions. We can create VPCs and VNets and VCNs across all cloud service providers. Not only will we create the VPC, we'll create the associated subnets, the route tables. All of that can be programmed through the Aviatrix controller. Right? Once the logical construct of VPC or VNet has been established, then it's about deploying the Aviatrix platform in a spoken transit type of architecture, right? You can see it doesn't matter which region or which cloud we're working in, or the features and capabilities of that cloud provider. We provide a very consistent architecture across regions, across clouds. right? So you can see between region 1, region 2, spoken transit type of architecture, and we just simply extend that to another cloud provider, to another region, et cetera. The security insertion here, notice that it's inserted at the transit layer. And again, you have full control of how you want to send traffic to the firewall for inspection. Here we can see the consistent networking aspect between a VPC in AWS and a VNet in Azure and a VPC in GCP. Right? The consistent automation, like I mentioned previously, because we are an official Terraform provider and our Terraform provider is multi-cloud lingual and multi-cloud aware, we can use the same Terraform configuration to deploy this type of architecture in different cloud environments. There's now the need to rewrite your existing Terraform configuration when you move to a new cloud. With Copilot, you'll have the visibility and troubleshooting, because if you think about it, once the Aviatrix gateways make up the data plane, right? Like I mentioned previously, the Aviatrix gateways, they produce very rich logging information, very rich NetFlow v9 information, and all of that is sent to Copilot, right? And so Copilot can provide you with a global visibility of what your entire cloud footprint may look like in different regions and different clouds. We build a dynamic topology live as your gateways are being instantiated. And we have full visibility into all the flows between your VPCs or between regions and between clouds, right? All of that visibility is available to you within Copilot. And we'll jump into that in a demo in a brief minute. Aviatrix also has a patented capability, which we call multi-cloud network segmentation. Right? So if you were to extend segmentation, for example, let's say these blue locks here, they're for your prod environments, and the red is for dev, right? As you're building out between regions and between clouds, you may want prod to be able to talk to prod in other regions or in other clouds, but you don't want prod traffic to intermix with dev traffic and vice versa, right? If you were to do this manually, it'd be a lot of manual manipulation of route tables or route tables to control that traffic. With Aviatrix and our segmentation capabilities, it's very easy. You can say prod can talk to prod, dev can talk to dev. We can visualize exactly who can talk to who. And right now, we also have an extended capability where we can do micro segmentation, meaning that if you have different subnets within a particular VNet or a particular VPC, we can provide that segmentation between subnets, intra VPC or intra VNet. One other thing I like to touch on before hopping over to the demo is now that the Aviatrix gateways are deployed in your various VPCs, and the Aviatrix gateways is making up the data plane. There's a lot of very rich telemetry information available as traffic is passing through the gateways. If you recall, in an on-premise data center, right, you have your security point at the edge firewall or at the edge gateway, right, where everything ingressing and egressing can be inspected by that firewall. Well, in a cloud environment, it's very different because, like I mentioned, every VPC is one hop away from the open internet, right? With the Aviatrix gateways, as they're deployed in various VPC and various VNets, if you're allowing traffic directly out from those VPCs and VNets, since the gateways in those VPC and VNets, they see all traffic, right? We can alert you if there's any traffic going to a known malicious domain, right? If it's a known Tor exit node, or if the IP has been associated with Bitcoin mining or something like that, right? Copilot gets an active threat feed that it consumes, and because Copilot sees all the flows in and out of your cloud environment, it can then alert you when it sees something anomalous. And if you have your own custom threat feeds, you can add those into Copilot as well. And we can talk a little bit more about that in the demo also. Last slide here before we jump into the demo. This is pretty much the value proposition for Aviatrix. We can make your cloud journey extremely fast and agile. if you're in AWS today and due to mergers and acquisition or something like that, you're now moving to a new cloud environment. Aviatrix can help solve for that, right? We can help solve for firewall insertion. If you have any overlapping IPs, we see those during mergers and acquisitions as well, where two organizations may be using the same IP space in their cloud environment. We can solve for the overlapping IP challenge also. Because our gateways provide very rich telemetry, we can give you greater control and visibility, as well as troubleshooting capabilities. Okay. And with regards to how we can very easily segment and provide that segmentation visibility within Copilot, anytime there's a compliance or audit type of requirements, the Aviatrix can be leveraged for that to show exactly how things are segmented within your environment. And lastly, we all know cloud talent is very difficult to come by these days. With Aviatrix, because we make each cloud provider look and feel the same, right? It can help kind of uplift your existing staff to work in cloud environments and build cloud infrastructure with the Aviatrix platform. All right. What I'll do now is I'll hop over to my demo environment, and we'll just kind of walk through some use cases and some features and capabilities we have within our platform. All right, let me log into my controller here. All right, so what you're looking at here, this is the Aviatrix controller. Like I mentioned, the controller is used for the build aspects of the Aviatrix platform, and Copilot is used for the day two visibility and troubleshooting. So I'll just spend a little bit of time in the controller, and then we'll hop over to Copilot and give a brief demo of Copilot as well. Right? Like I mentioned, the controller could be instantiated in the cloud service provider of your choice. The features and functionalities are exactly the same. For my environment here, it's onboarded in AWS. And what I've done is then I've onboarded different cloud accounts here. So these are the different cloud service providers that we support. Right? If we go to access accounts here, you can see I've onboarded pretty much all 5 flavors of the popular cloud service providers here. Right? Once the controller once your cloud accounts have been onboarded into the controller, then it's really a matter of let's start building. Right? Like I mentioned, we can go to useful tools here and use the controller to build our VPCs and our VNets if we like. Right? Here you can see if I want to create a new VPC, I select the cloud type of AWS. I give the VPC a name. Let's say, for example, AWS US East 1. This is going to be for my transit, right? US East 1. I would define the CIDR here, and then because this is going to be a transit, I'm going to leave it checked. If this VPC is going to be for a spoke, I'll simply uncheck that. Right? Similarly, if we're going to go into Azure, you can see the look and feel is very much the same. The cloud type is Azure. You would still give the VNet a name. This will be Azure here. I would select the region I want to build this particular VNet in, the CIDR that I wanted to assign, and then hit create. Right? If your organization has existing VPCs and VNets already in production, when the controller onboards your cloud account, we ingest that information as well. So you can build brand new VPCs and VNets through our controller, but if you have existing ones, we can leverage those for the build as well. Right? Once the logical construct of a VPC and VNet has been created, then it's really a matter of creating the spoke and transit architecture. So you'll spend a lot of time under multi-cloud transit setup here, and the interface is pretty straightforward. It prompts you whether you want to build a transit or a transit Aviatrix gateways, spoke Aviatrix gateways, or if we want to attach the spokes to the transit for a particular region. Let me just walk through this example really quick. Let's say I'm building an AWS, and again, because I'm building a transit, I'll say, AWS US East 1 transit. Okay. I select the region that I want to build in. Here are the VPCs that I've already created within that particular region. Right. I'm going to select the transit VPC. I select the public subnet that I want to deploy the Aviatrix gateway in. right? And then the instance size, now hit create. What the controller will do then is go out and create this VPC or create this Aviatrix gateway in that particular VPC. We always recommend deploying our gateways in a redundant fashion. So for example, in a particular VPC, if we're doing the spoken transit type of architecture, one of the transit gateways would be deployed in one availability zone. And then here, I would simply choose my US East Transit and insert it into another availability zone, right? I can insert into any other one. Right? So that way, the Aviatrix gateways can survive availability zone issues if those are encountered. Similarly, if I were to go to Azure, you can see the look and feel is exactly the same, right? We would still assign the gateway a name. I'll change that to Azure now. I select the region I want to build the gateway in, the particular VNet I want to build in, the public subnet where we deploy the gateway, and then hit create. So this is building the transit, and then this is building the spoke. You can see here through the interface, the look and feel is exactly the same, whether you're building a transit or spoke. You would just choose like a spoke VPC rather than a transit VPC. Right? Our customers, after they've gone through the process of building a couple times, they become experts at building in any cloud environment, right? Just because through Aviatrix, we abstract the complexity of each of the native constructs, and we allow our customers to build like an expert without having to be an expert. Let me talk a little bit about the firewall insertion because the theme for these 3 hours is firewall focus. Like I mentioned, with the Aviatrix controller, we can actually instantiate the creation of the VM series, right? So let me just go to the firewall network setup here and go to firewall, right? So what you'll see here from the Aviatrix controller, we can launch and associate a firewall instance. Let me just finish, wait for this to finish rendering here. Okay. So what you'll see is I'm going to deploy a Aviatrix, I'm going to deploy a new VM series, right, to my Aviatrix infrastructure here, right? So I'm going to deploy in transit VPC US West 1. I'm going to attach it to the HA gateway in that particular VPC. I'm going to give the firewall name. So I can say AWS, US West 1, PA, and this will be my third firewall because I already have 2 created within that transit currently, right? For the firewall image, I can select any image I like, right? The VM series bundle 1 is for threat protection. If bundle 2, it's all of the VM series security services. Or if your organization, if you have the VM credits and you want to use BYOL, we support that option as well. Right? I can select the image version that I want to deploy, the firewall instance size that I choose. Then it's really a matter of just matching up interfaces, right? Because this is a management interface subnet, I'm going to put this for the firewall management 1B, right? Because this is my HA gateway, I want to put it in the second availability zone, right? For the egress, again, we're just matching things up. I'm going to do egress 1B. Okay. What I can also do is go to advanced and if you have an existing configuration or panorama that we want the VM series to auto-register to, we can do all of that within the controller here, right? So what I'm going to do is I'm going to give the IAM role to allow me access into the S3 bucket where my Bootstrap package resides. And I'm also going to give it the actual S3 bucket where the Bootstrap package is, right? And then what I'll do is I'll go ahead and go launch, right? So within 15 to 20 minutes, the controller is going to go out and build the VM series, which you see auto-populate in Panorama. All of this is orchestrated through our controller here, right? While this is building, what I'll do is let me just duplicate this and show you some other things that we have going on with the controller and our integration with Palo Alto Networks. Notice here under vendor integration, right? If I just do show, what vendor integration allows us to do is allows the controller to control the route tables in the virtual router of that VM series. Right? So if I just do show here, what you'll notice is this is a PA, one of my PAs in AWS. This is the virtual router, right? And here are the Aviatrix populated routes from the Aviatrix controller. Right? We can do this if your organization doesn't have Panorama, or if your organization has Panorama, we support that Panorama as well, right? So I can go switch over to Panorama, I'll hit show. And what you'll see here is this is the controller controlling the template and template stack that the Panorama will then push down to the managed firewalls. So complete control of your routing environment across regions, across clouds with Aviatrix, and we can also orchestrate the routing of the VM series here as well. All right. What I'll do now is we'll shift our focus away from the build aspects, and let's talk about Copilot a little bit, right? Again, Copilot is the day two visibility troubleshooting analytic tool that accompanies Aviatrix. When our gateways are deployed, our gateways send very rich logging and NetFlow information to Copilot, and Copilot visualizes all of this within its dashboard here. Right? What you'll also notice is when our gateways are deployed in the AWS VPC or VNets, we have visibility into the compute instances running within those VPCs and VNets as well. So you can see here, I have visibility into some of my servers here in my VPCs and VNets, and the Copilot has visibility into the amount of traffic that's come in and going from those instances. So again, if your organization has multiple accounts, multiple regions, multiple clouds, within one dashboard here, you have full visibility of the total traffic that's passing between your cloud environment. I'm going to hop over to the topology view here. And the topology view, what this does is as your gateways are deployed, right, the topology view here is updated automatically to give you an accurate and up-to-date visualization of exactly what your cloud footprint looks like. Many times when we are working with customers, we'll ask them, do you have an up-to-date network diagram? It's either not up-to-date or it's not available, right? Due to the thermal nature of cloud, VPCs and VNets get spun up and torn down. With Copilot in the topology view, you'll always have an accurate depiction of what everything looks like. Notice here, these nodes are actually the VPCs or VNets within each of the cloud providers. So what you'll see is that these are the transit VPCs and VNets, and these are the spokes. So you can see I'm in a couple of AWS regions, a couple of Azure regions here, a GCP and OCI region, and everything is interconnected here, right? Each of these nodes, I can expand that, and what this will do is highlight the resources I have deployed within that particular VPC, right? You can see my Aviatrix gateways here, but you also have visibility into the compute that's available within that particular VPC as well. Right? Our gateways can essentially glean the metadata that's available within the VPC to provide you with information about the compute resources available within different VPCs, different VNets. If I highlight one of the Aviatrix gateways here and hit diagnostics, this is where your troubleshooting capabilities have been returned to you, right? You can perform things like ping, you can do trace route, we can test layer 4 connectivity, we can view all active sessions going through the Aviatrix gateways. We can even perform packet capture directly on the data plane, right? For those of you that have worked in cloud environments and have ever had those hair-pulling moments where you think the VPC attachment to the TGW should be working and the routes are there, but traffic is not passing, right? How do you troubleshoot that? You have to set up bashing hosts, every hop along the way, or else open a support ticket with AWS and say, what they'll tell you is, hey, enable VPC flow logs, right? Wait for those to collect, start troubleshooting. If you don't have, if the VPC flow logs do not provide the info, then they'll have you enable enhanced VPC flow logs and output to an S3 and go about troubleshooting that way, right? With Aviatrix, because you have direct access to the data plane, you can do traffic, or you can do troubleshooting on the data plane itself, just like you were on-prem, right? So we can set up packet captures to determine, hey, is a TCP three-way handshake taking place between host A and host B? If not, why is it not taking place, right? So these are the capabilities that exist within the Aviatrix platform from a troubleshooting perspective. Let me hop over to Flow IQ. Like I mentioned, let me just update that to the last day, for example, right? Because our gateways are providing very rich logging and netflow information for all traffic that's passing through those gateways. All of this is archived under Flow IQ here, right? We have actual flow diagrams, Sankey charts available showing the amount of traffic passed, from host to host and how that compares to other hosts. The raw NetFlow v9 records are all available here as well. So for example, going back to that TCP three-way handshake, right? I can enable all the TCP flags that's available within NetFlow, sort that down to the source and destination, and then save and then apply the change so that I can see exactly how traffic is passing from point A to point B, right? Another interesting use case that we have is called App IQ. So with App IQ, what this allows us to do is to understand if there's anything in the path that may not allow traffic to pass between two resources, right? So for example, let me just type in, I have a server in GCP and one of my hosts in AWS, I know the IP address 50.12. This is AWS web server here. I'm just gonna see if I can do ICMP from this host in GCP to this host in AWS. I'm gonna hit submit. If you were to do this, in using native cloud constructs, right? In GCP, you'll be checking the route tables, the IPsec tunnel, the firewall rules, the tags associated with those firewall rules. That's just on the GCP side. If we hop over to AWS, then you'll have to view the VPC attachment, transit gateway, network security group, all of that information, right? So you have to go through those steps in order to understand what may be causing an issue between host A and host B. Right? This is taking a little bit longer. Usually it's done within 10 to 15 seconds. We'll give it another few seconds here. Live demo, so perhaps there's some underlying issue with one of my hosts here, so I apologize for that. Let me just go to the security domains, right? Like I mentioned, the multi-cloud network segmentation, we can provide segmentation extremely easy between regions and between clouds. So let's say, for example, we want to see exactly how things are segmented within my cloud environment here, right? So you can see blue is shared services. So if I highlight shared services, all of my regions in the different cloud providers, they have access to shared services. Right? But for example, if we see this is purple, purple is prod. If I go to any of my prod VPCs or VNets or VCNs, notice that prod can talk to shared services, it can talk to on-prem, it can talk to third party, but it can't talk to dev, right? And similarly, if I highlight dev, dev can talk to shared services and on-prem, but they can't talk to third party, they can't talk to production. We can extend that segmentation extremely easy across regions and across clouds. And here's another view of exactly how things are segmented. One last thing I'd like to mention is, because the Aviatrix gateways, they see all traffic ingressing and egressing from your VPCs and VNets, we can highlight if there's any traffic going to no malicious IPs or no malicious domains. And we do that under Threat IQ here, right? So with Threat IQ, because Aviatrix, the Copilot has an active threat feed, when there's traffic going to a no malicious IP, we provide alerting on that, and we can even block subsequent communications from taking place with ThreatGuard. With the custom threat list, if you have any your own threat list that you would like to add into Copilot, we can support that type of those custom threat feeds here as well. We have around 5 minutes left for questions. If there's any questions I can help address at this time. Let me see. All right. Any questions in the Q&A? Yep. So it looks like there was a question about the Palo Panorama integration. So with the vendor integration here, right? The notice here in when you set up the vendor integration, you will provide the template name as well as the template stack name of that the controller will manage in terms of the route tables, right? So from the controller, it'll push that to Panorama under this template and template stack. And then from the firewall itself, it would then get that information from Panorama. If I go back to my Panorama instance here, let me just go to device. Actually, let me go to Panorama. Looks like that firewall is still coming up. If we give another 5 minutes, it should populate here. Thank you for that question. Were there any other questions about Aviatrix that I can help answer at this time?